Hello friends, in today's podcast we are going to discuss general principle and process of isolation of the elements. This podcast is brought to you by www.chemistrynotesinfo.com. You can search us at Google, Facebook, Instagram, YouTube, Pinterest, everywhere. To search us, search @chemistrynotesinfo. Let's start with some definitions. First, what is mineral? These are the naturally occurring chemical substances in the earth crust obtained by mining. What is ores? Only few minerals are used as source of that metal. Such minerals are known as ores. Gangue. Ores are usually contaminated with earthy or undesirable materials known as gangue. Metallurgy. The entire scientific and technological process used for isolation of the metal from its ore is known as metallurgy. Concentration of the ores. The removal of earthy and siliceous impurities, that is gangue or matrix, from the ore is called concentration of the ores. First is hydraulic washing. The process by which lighter earthy particles are free from the heavier ores particles by washing with water. Second, magnetic separation. This method of concentration is employed when either the ore or impurities associated with it are magnetic in nature. Example, chromate. Third, froth flotation. This method is based upon the fact that surface of sulfide ores is preferentially weighted by oils, while that of gangue is preferentially weighted by water. Fourth, leaching. This process consists in treating the powdered ore with the suitable reagent which are selectively dissolved the ore but not the impurities. Leaching of alumina from bauxite. Ore of aluminium bauxite usually contain SiO2, iron oxide, TiO2 as impurities. The concentration is carried out by digesting the powdered ore with the concentrated solution of NaOH at 473 to 523 Kelvin and 35 to 36 bar pressure. This way, Al2O3 is leached out as sodium aluminate, leaving behind 3H2O plus Al2O3 plus 2NaOH gives 2NaAlOH4. The aluminate in solution is neutralized by passing CO2 gas and hydrated Al2O3 is precipitated. That is 2NaAlOH4 plus CO2 gives Al2O3 dot XH2O plus 2NaHCO3. NaHCO3 remains in the solution and hydrated alumina is filtered, dried and heated to give back pure Al2O3. That is Al2O3 dot XH2O on heating gives Al2O3 plus XH2O. Other examples. In the metallurgy of silver and that of gold, the respective metal is leached with a dilute solution of NaCN or KCN in the presence of air for O2, from which the metal is obtained later by replacement. For example, 4M plus 8CN minus plus 2H2O plus O2 on heating gives 4MCN2 minus plus 4OH minus, where M is any metal like silver or gold. So 4M Cn2 minus plus Zn gives ZnCN4 2 minus plus 2m. Dear friends, to learn or to get the notes of this chapter in PDF form, you can visit our website www.chemistrynotesinfo.com, or you can also download PDF notes of this chapter from our Telegram channel. To search us on Telegram, search @chemistry notes info. There are some channel which copy us or make fuzzy or unimportant, unrealistic channels on Telegram also with chemistry notes info name. So it is better to find that channel from our website and go to that channel and join that channel. Let's continue our discussion. Extraction of crude metal from concentrated ore. The concentrated ore must be converted into a form which is suitable for reduction. The process used to obtain metal in free state from concentrated ore is called extraction. It involves two chemical processes: conversion of the ore into metallic oxide or de-electronation of ores. Metals usually present as hydroxides, carbonates, and sulfides. Depending upon the nature of the minerals present in the ore, the following two presents in the ore. The following two methods are used for conversion of ore into their respective oxides, that is calcination and roasting. First we learn calcination. It is the process of converting ore into its oxide by heating it strongly below its melting point, either in absence or in limited supply of air. During calcination, following changes occur. First, moisture is driven out. Second, volatile impurities of S, As, and P are removed as they are volatile oxides. Third, water is removed from hydrated oxides and hydroxides ore, that is Al2O3 dot 2H2O. Bauxite gives on heating Al2O3 alumina plus 2H2O. Fourth, carbonates ore are converted into their respective oxides by loss of carbon dioxide. CaCO3 limestone on heating gives CaO calcium oxide plus CO2. Now we are going to learn roasting. It is the process of converting an ore into its metallic oxide by heating strongly at temperature insufficient to melt in excess of air. This process is usually used for oxide ores. Following changes occur during roasting. Moisture is removed, organic matter is destroyed, non-metallic impurities like that of S, P, and Ar are oxidized and removed as volatile gases. That is, S8 plus 8O2 gives 8SO2. P4 plus 5O2 gives P4O10. 4As plus 3O2 gives 2As2O3. Ores are generally converted into metallic oxides. 2ZnS plus 3O2 gives 2ZnO plus 2SO2. 2PbS plus 3O2 gives 2BbO plus 2SO2. 2Cu2S plus 3O2 gives 2Cu2O plus 2SO2. Like calcination, roasting is also carried out in the reverberatory furnace. Thermodynamic principle of metallurgy. For any process gives free energy change, del G is given by del G is equal to del H minus T del S, when del H is the enthalpy change and del S is the entropy change and T is the absolute change for any reaction. Del G dash is equal to minus RT ln K, where K is the equilibrium constant of the reactant product system at temperature T. A negative del G implies a positive K in equation, and this can happen only when reaction proceeds towards product. Application: extraction of iron from its oxides. Oxides ores of iron after concentration through calcination roasting are mixed with limestone and coke and feed into a blast furnace from its top. Here the oxide is reduced to the metals. FeO plus C gives Fe plus CO, and FeO is reduced and C is oxidized to CO. FeO gives Fe plus half O2. C plus half O2 gives CO. At 500 to 800 Kelvin, 3 Fe2O3 plus CO gives 2 Fe2O4 plus CO2. Fe3O4 plus 4CO gives 3 Fe plus 4 CO2. 2 Fe2O3 plus CO gives 2 FeO plus CO2. At 900 to 1500 Kelvin temperature, C plus CO2 gives 2CO. FeO plus CO gives Fe plus CO2. Limestone is also decomposed to CaO, which removes silicate impurities of the ore as a slag. CaCO3 gives CaO plus CO2. CaO plus SiO2 gives CaSiO3. The iron obtained from blast furnace contains about 4% carbon and many impurities in smaller amount like SpSiMn. This is known as pig iron. Extraction of copper from cuprous oxide. Most of the ores are sulfide and some may also contain iron. The sulfide ores are roasted or melted to give oxides. 2Cu2S plus 3O2 gives 2Cu2O plus 2SO2. The oxide then can be easily reduced to metallic copper using coke, that is Cu2O plus C gives 2Cu plus CO, and slag of iron silicate is produced. FeO plus SiO2 gives FeSiO3. Following reaction also take place. 2FeS plus 3O2 gives 2FeO plus 2SO2. FeO plus SiO2 gives FeSiO3. 2Cu2S plus 3O2 gives 2Cu2O plus SO2. 2Cu2O plus 2Cu2S gives 6Cu plus SO2. Extraction of zinc from zinc oxide. ZnO plus C in presence of coke at 673 Kelvin temperature gives Zn plus Co. The reduction of zinc oxide is done by using coke. The metal is distilled off and collected by rapid chilling. Extraction of aluminium. Alumina Al2O3 is mixed with Na3AlF6 and CaF2, which lowers the melting point of the mixture and brings conductivity. Fused mixture is electrolyzed. Steel cathode and graphite anode is used. The graphite anode is useful for reduction of metal. The overall reaction are as follows: 2Al2O3 plus 3C gives 4Al plus 3CO2. The electrolytic reduction are at cathode Al 3 plus 3 electron gives Al. At anode C plus O2 minus gives CO plus 2 electron, and overall reaction is C plus 2O2 minus gives CO2 plus 4 electron. Extraction of copper, low grade ores and scraps. Copper is extracted by hydrometallurgy from low grade ores. It is leached out using acid or bacteria. The soil containing Cu2 plus is treated with scrap iron or hydrogen. Cu2 plus H2 gives Cu plus 2H plus. Oxidation reduction. Besides reduction, some extraction are based on oxidation, particularly for nonmetals. The extraction of chlorine from brine 2Cl minus plus 2H2O gives 2OH minus plus H2 plus Cl2. Refining. The process of purifying the crude metals is called refining. Some methods of refining are as follows. Distillation. This is very useful for low boiling metals like zinc and mercury. The impurities the impure metal are evaporated to obtain the pure metals as distillate. Liquefaction. In this method, a low melting metal like tin can be made to flow on a sloping surface. In this way, it is separated from higher melting impurities. Electrolytic refining. In this method, the impure metal is made to act as anode. A strip of some metal in pure form is used as cathode. They are put in a suitable electrolytic bath containing soluble salt of some metals. The more basic metal remains in the solution and less basic ones go to the anode mud. At anode, M gives N plus Ne minus. At cathode, Mn plus Ne minus gives M. Zone refining. In this method, a circular mobile heater is fixed at one end of a rod or the impure metal. As heater more forward, the pure metal crystallizes out of the metal and impurities pass on into the adjacent molten zone. Vapor phase refining. The crude metals is free from impurities. By first converting it into a suitable volatile compound by heating it with specific reagent at a lower temperature and then decomposing the volatile compound at some higher temperature to give the pure metal. Example, Mond process and Van Arkel method. Chromatographic method. This method is based upon the principle that the different components of a mixture are adsorbed to different extent of an adsorbent. For example, in column chromatography, different components of the mixture are adsorbed to different extent depending upon their polarity. Thank you to listening this episode. This episode is brought to you by www.chemistrynotesinfo.com. You can download notes of this PDF in PDF form from the description of this podcast. You get link in the description to download PDF notes and to visit website to read out these notes. Thank you to listening this podcast. Do like, follow, and subscribe this podcast to listen more chemistry knowledge and science knowledge episodes. Thank you to listening this episode.